the general theme of what I'll describe is hunting for aliens, and the subtitle is that science is better than politics. The sky is not classified. We can study it scientifically. And moreover, we can look for better role models than our politicians. By that, I mean, if we have neighbors that are more accomplished than we are, we could be inspired by them, especially if they arrive at our backyard. And we are all familiar with what Enrico Fermi said back almost 70 years ago. He said, "Where is everybody?" And that is a question that every lonely person asks. And what you tell lonely people is, you should be proactive. You should search for others. Don't assume that you are that attractive they will come to you. And moreover, they might be in front of you, just ignoring them. And so Enrico Fermi didn't build telescopes, didn't search. He was just assuming that sitting at lunch, they would show up. And that's not really the way to gain new knowledge. And what people often say is that it's an extraordinary claim to imagine something like us near another star. I would argue that it's an ordinary claim, because there are hundreds of billions of stars like the sun in the Milky Way galaxy alone, and at least a few percent of them have a planet the size of the Earth, roughly at the same separation. So I would argue it's an ordinary claim if you have similar circumstances to end up with something like us, and in fact with things that are better than us if they had more time to develop their technologies. And an ordinary claim requires ordinary evidence. Now, the point is that very often life is a self-fulfilling prophecy. So it's better to be an optimist than to say, let's search, and then you might find something. And one reason that I seek higher intelligence in interstellar space is because I don't find it very often here on Earth. And as I mentioned, we really need an example from someone that was more accomplished than our civilization, because when I read the news every day, I often get depressed. And to gain new knowledge about our cosmic neighborhood, we really need to invest time and money and effort, because new knowledge does not fall into our lap. The low-hanging fruit already was picked up. And I placed a bet against Elon Musk a day after Peter Thiel, following the elections, said that nobody should bet against Elon Musk. And I found what he said to be unlikely. He basically argued that we should move to Mars because we are probably alone and we have a responsibility to preserve the human species. And if we stay on Earth, we might be killed by some single point catastrophe. And I argue that it's very unlikely that we are alone. In fact, it's very likely that there were others before us, billions of years before us, and they had plenty of time to reach our backyard. And so I suggested that I put 1% of my net worth against 1% of Elon's net worth, and we put it in a common pool. It will be $4 billion based on his net worth, and search for technological objects near Earth that originated from another civilization. And if in 10 years we don't find anything, I'm willing to put a second 1% of my net worth. But without searching, we will not find anything. And obviously, the public cares a lot about this question. And the other point is we are investing $2.4 trillion worldwide in military budgets. And if we were to use that money for space exploration, we could send a CubeSat towards every star in the Milky Way galaxy within the coming century. So it's just a question of priorities. And personally, speaking about life, I would love if I had the opportunity to visit one place in the solar system. It would not be Mars. It would be a satellite, a moon of Saturn called Titan, because it's the only object in the solar system that has liquid on its surface, in addition to Earth. Earth has oceans, lakes, rivers of water, Titan has the same lakes, oceans, rivers of methane and ethane. It's about 3 times cooler relative to the absolute zero. It's 94 degrees Kelvin versus room temperature here on Earth. But there is liquid, methane and ethane at that temperature. And what I would like to do is go fishing there. If I find any fish, it would mean that life can exist in a different way than we know it. Because we are always assuming life based on liquid water, the chemistry of liquid water. There would be actually a mission going to Titan called Dragonfly that will be launched in 2028. But speaking about intelligent life, there were 3 reports, as you all know, from the Director of National Intelligence to the US Congress, starting in June 2021, reporting about unidentified anomalous phenomena. And the scientific community ignores those. There was a new office established in the Pentagon, the All Domain Anomaly Resolution Office, as a result of these reports. But they are not doing science. They are just attending to military reports, and if they find what 97% of the objects are, they're happy. And they're mostly concerned about the national security, so they want to figure out if any of these objects was produced by adversarial nations. From a scientific point of view, even if 1 in a million came from another star, that would be a breakthrough. So it's a very different objective than the government has. We shouldn't rely on government to tell us what lies outside the solar system. So that's why I'm leading the Galileo project that over the past 3 years built an observatory dedicated for looking at the sky all the time in the infrared, optical, radio, and audio. And we have one functioning observatory at Harvard University. You see here an illustration of the various instruments we're using. The one that looks like half a sphere is our main workhorse. It's a set of 8 cameras looking at the entire sky in the infrared. And we are analyzing the data with machine learning software. Altogether, we hope in the coming years to have 4 observatories, not just 1. The next one will be in Pennsylvania, and the one after that in Nevada. Those 2 we hope to finish by the end of the summer of 2025, and then 2 years later we'll have an even more capable observatory that will be used also for STEM education in Indiana. And in addition to the study of unidentified objects in our sky, from the astronomy point of view, astronomers for the first time over the past decade discovered the first interstellar objects. These are objects from outside the solar system that are identified by the fact that they're moving too fast to be bound by gravity to the sun. And the first one that was detected was noticed by US government satellites. They monitored the Earth and they found a meteor, which is basically an object colliding and burning up in the Earth's atmosphere. And it was moving too fast to be bound to the sun. We discovered it with my student in a catalog that NASA compiled. And the collision was on January 8th, 2014. So this is the first reported interstellar meteor. And about almost 4 years later, a much bigger object, the meteor was half a meter in size, but an object that is bigger than even Starship, about 100 meters in size, was spotted when it came close to Earth, and it was spotted by a telescope in Hawaii, was given the name Oumuamua, which means a scout in the Hawaiian language. And Oumuamua was really unusual in the sense that it had most likely a flat shape like a pancake, and was pushed away from the sun by some mysterious force without showing any cometary evaporation. The interstellar meteor was unusual because it only disintegrated in the lower atmosphere, where the stress was much larger than on any other meteor in the catalog that NASA compiled, hundreds of them. And finally, there was a comet that looked just like the ones we are familiar with in 2019. So out of three, the first two looked unusual, anomalous. And I was asked, why doesn't it convince you that Oumuamua, for example, was natural if the comet was similar to natural objects? And I said, when you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal. These are two different objects. This is an artist's illustration of Oumuamua, and the amount of sunlight reflected from it changed by a factor of 10 as the object was tumbling every 8 hours. People often think of it as a cigar but shaped object, but it was not. It was actually, most likely at the 90% confidence, it was actually a flat object, pancake-like, based on modeling of the reflection of sunlight as the object was tumbling. And there was no evaporation from this object, yet it exhibited a push away from the sun. The question was, what is pushing it? And I suggested that maybe it's technological in origin, as it's just the reflection of sunlight from the wall of this object that is pushing it. Sort of like in the case of a light sail or an empty trash bag from another civilization, or a broken piece of a Dyson sphere megastructure that another civilization built. We just don't know, but it didn't behave like a rock of the type that we're familiar with, or a comet. And of course, we are familiar with space trash that we are producing. In fact, on January 2nd, this year, 2025, the official body that announces new asteroids, the Minor Planet Center, announced a new asteroid, 2018 CN41, and then within 17 hours after that, it turns out they figured out that it was actually the Tesla Roadster car that was launched by SpaceX in 2018 as a dummy payload on the Falcon Heavy. So here is an example where astronomers say, here is an asteroid, here is a rock, but it's actually technological in origin. This happened just a few months ago. And then in December 2024, there was a paper written by astronomers that declared a dark comet among a group of dark comets, and we just wrote a paper with my postdoc showing that the orbit of that dark comet is actually that of a spacecraft that was launched by the Soviet Union in 1965. And then in September 17th, 2020, the same observatory that discovered Oumuamua also discovered another object that they called 2020 SO, which ended up being, they thought it's an asteroid, but it turned out to be an upper stage of the Surveyor 2 probe that was launched towards the moon in 1966. So all I'm saying is space trash, technological objects could be confused as asteroids by the mainstream astronomy community. And maybe Oumuamua was just that. And right now, the experts on comets would argue that Oumuamua was actually a dark comet, which is an oxymoron, because a comet is identified by its cometary tail. If you don't see the cometary tail, how do you know it's a comet? It's just like classifying elephants or any other animal as zebra without stripes. Or if you think about koalas, you might say koalas are monkeys without a tail. No, it's a different animal. You can't insist that objects must be comets by giving them the name dark comet. They might be a completely different beast, technological in origin. So the next revolution that will resemble the one that Copernicus made, the Copernican revolution, in which he realized that we are not at the center of the universe, not at the center of the solar system, but the sun is at the center of the solar system. The next one would be that we are not at the intellectual center of the universe. And for that, we need to be open-minded. And I wrote a paper just last month suggesting a space telescope that could find objects that are of the size of the space trash that we launched that may have come from outside the solar system. When such objects get very close to the sun, we can see them. It's just like having the lamppost and finding keys under the lamppost close to the sun. And the point to keep in mind is that most stars formed billions of years before the sun. The sun formed only in the last 1/3 of cosmic history. And it takes a spacecraft like Voyager only 1 billion years to go from the solar system to the opposite side of the Milky Way galaxy. So there was plenty of time for any technological civilization similar to ours to evolve on another star like the sun and send their equipment to our backyard. And we should look for it. We haven't searched. Now, with respect to the interstellar meteor, it offered a very unique opportunity because we knew where it exploded and we decided to go there and collect the materials from that site. And it exploded above the Pacific Ocean, so we had an expedition to the Pacific Ocean. The location was about 50 miles away from Papua New Guinea, outside the territorial waters of Papua New Guinea. And what the government provided us, first of all, they confirmed that indeed this meteor was from an interstellar origin at the 99.999% confidence. And they also provided the light curve for the explosion, which had 3 flares. And the lowest explosion was less than 20 kilometers above the ocean surface. So it meant that the object was able to sustain its integrity at very high stress because it was moving really fast. An iron meteorite could not have survived at that elevation. So we went to the Pacific Ocean. Here you see us on the ship, the deck of the ship. The expedition cost about $1.5 million and took place in June 2023. And here are some photographs from that expedition. We used a magnetic sled, basically a sled that is covered with magnets on both sides. We placed it on the ocean floor and went back and forth 26 times across the region of interest. And there will be a Netflix documentary coming out within a year. The filming crew was on the ship, and you can see them on the bottom left and middle pictures here. And they were taking photos of me jogging at sunrise, as I usually do on land. And at the end of my jog, which lasted an hour and a half, they wanted to film it. The director asked me, Avi, it looks like you're running. Are you running away from something or towards something? And I said both. I'm running away from scientists, my colleagues, who have very strong views without seeking evidence. And I'm running towards a higher intelligence in interstellar space. So we collected the materials from the sled that you see on the left on a rainy night. And we eventually put everything in this suitcase, the black suitcase you see on the right-hand side. And it was shipped by FedEx to my home. And I brought it to the laboratory of my colleague at Harvard, Stein Jacobson, a world-renowned geochemist who is standing here on the right side of my image here. And to the left is a summer intern, Sophie Bergstrom, who went through the materials we brought back and found most 90% of the spherules, that the molten droplets that were identified inside the materials. And you can see here one of them very easily distinguished from the background sand. These are molten droplets, that some of which are meteoritic in origin. We collected them with tweezers, as you can see. And altogether, we had 850 of those molten fragments that were collected, and about 20% of them looked different than the ones that can be associated with solar system materials. And we call them differentiated because they had the chemical composition that emphasized some elements from the periodic table much more than you find in solar system materials. So in particular, half of those differentiated spherules were of a special type that you see here. These are 5 of the special type molten droplets. And what you see is the abundance of elements relative to solar system abundances, which are marked by 1. And the elements are at the bottom of this diagram. You can see, going from left to right, the elements on the right are more volatile, so they can be lost in an explosion. And indeed, we see that they are deficient. I mean, the spherules, these special type spherules, do not have much of volatile elements. They were lost in the explosion, probably of a meteor. But some elements, like beryllium, lanthanum, uranium, that's why we call them belau, are up to 1,000 times more abundant than the materials that made the solar system. And therefore, we think that might be, if one possibility to explain it is if they came from outside the solar system. And to find out what the nature of the meteor, we are planning the next expedition. And for that, we hope to use special equipment that will allow us to pick up bigger pieces of the original object. And here you see me and the navigator of the first expedition outright looking at the sunset on the last day of the expedition. We hope to use a ship called Nautilus that has a robot, a remotely operated vehicle that you see on the left. And we will use it on the ocean floor, place it there, and have a video feed that will allow us to see all the pieces that we pick up. The previous search was blind, and now we will be able to see what we are picking. The only challenge is that this expedition, in fact, we have a Nautilus reserved for August of this year, but we don't have the funding to pay the down payment for the ship, which would be $1 million. And if any of the people in the audience is interested in contributing to that, let me know. Another exciting development in 2025 is the Rubin Observatory in Chile that will start operations this summer. And it's basically a large telescope that could find an Oumuamua-like object every few months. It was funded by the National Science Foundation of the US government, and it will survey the southern sky from Chile every 4 nights. And it will use a camera that has 3.2 gigapixels, about 1,000 times more than your cell phone camera. So that will give an unusual inflow of data. And in that data, we will seek, together with my postdocs and students, we will try to find objects like Oumuamua or even UAP.
That's wonderful. So many advancements from the bet with Elon Musk and more. So I have a question for you. So if the US government comes out with the fact that, oh, we have proof, not only are the UAPs there, we've looked at them and whatever, how would you want to use your genius and your community of Galileo scientists and your postdocs? Would you want to ask the higher intelligent questions, or would you want to study spaceships or expand the periodic table or look for stars? What would be your highest excitement after you weren't spending your time proving the existence of ETs?
Right. So one thing is look for objects within the orbit of the Earth around the Sun. I estimated, based on the discovery of the interstellar meteor, that at any given time there are about 1 million objects within the orbit of the Earth around the Sun right now that are roughly the size of a person. And it's possible that most of them are rocks from interstellar space, but we should check whether among the rocks there might be some space trash, the technological debris. And in principle, that can be done. One just needs to design a new survey telescope that will be sensitive to that. And I have written a paper last month with the parameters of such a telescope. And if I had billions of dollars, I would invest a significant fraction of that in a survey telescope that would search for all the interstellar objects bigger than the size of a person within the orbit of the Earth around the Sun. And there are new ones coming in every minute. In fact, within the orbit of Mercury, every 5 hours, Mercury is 3 times closer to the Sun, and any object entering there every 5 hours is illuminated by the Sun much more, and it gets heated to about 600 degrees above absolute zero. So we could potentially see some evaporation from objects that get very close to the Sun, and from a distance we can figure out what they're made of based on their evaporation, and without the need to land on them or to wait for them to collide with Earth, because those interstellar meteors are very rare. Such an object collides with Earth once per decade, an object the size of a person. So it's a long time to wait, but it makes much more sense to search for objects that do not collide with Earth, because Earth has a small cross-sectional area, so it just has a very low probability of colliding with one of these objects by chance, and most of them are passing through between the Earth and the Sun, and all the time. At every given time there are 1 million of them, and so we can just search for something unusual among them. And so that's one thing I would do. And then there is the whole task of looking at objects that are near Earth that might appear to be anomalous. That's the UAP, and that we are pursuing with the almost 4 observatories. That's something in the planning, but we can build many more if we had more money. I mean, if we had $1 billion for that purpose, I could imagine hundreds of those observatories spread over through many different regions, so that we can get a good census of anomalous objects. That would give us access to hundreds of millions of objects every year. Just the same observatory that we have multiplied by a few hundred could give us within the next decade more than 1 billion objects that we monitor. That's a huge number, and it would be very interesting to check whether any of them are anomalous. That would be a much bigger sample than anyone had in the past, or that the government by chance detected. And finally, I really think that we should go after the materials from interstellar meteors. So there was the one I mentioned near Papua New Guinea. There is another one near Portugal, but I need the funding for the expeditions. And if I had the funding, I would conduct both expeditions.
I can't see why the millionaires, the governments, and the companies of the world and the everyday people can't get together to support these in truly valuable missions. Because, as you say, $1 billion in the grand scheme of things, when we talk about trillions and different things, is a small amount. And you're almost like, it's almost like mixing archaeology with astrology in material science and knowing where these rocks, it tells a story. We get closer to knowing where we come from, who we are. And that's, I wanted to ask you.
I should also mention before you ask that, the scientific projects right now are at the level that the biggest ones are at the level of $10 billion. We invested that much money in the Large Hadron Collider to discover the Higgs boson. We invested that much money in the Webb telescope. I'm just saying we can make a huge difference in the context of the question that we care about, that the public cares most about, even at a level that, an investment level that is 10% of that. And the astronomy community, defined its priorities for the next few decades. And at the top is a habitable world observatory looking for microbes at a cost of more than $10 billion, looking for microbes based on the composition of the atmospheres of exoplanets, planets around other stars. And I say, even if we find microbes, it wouldn't be as exciting as finding intelligent partners out there. And so we should at least invest, 10% or even a similar amount just to hedge our bets, because the signatures of intelligent civilizations might be much clearer than that of microbes.